In this video, we're going to talk about applications to exponential and logarithmic equations, especially dealing with compound interest and continuously compounded interest. So let's start off with compound interest. So the formula is given. A is the end balance. P is the principal or the starting amount. R is the interest rate. N tells me how many times it's going to be compounded in a year. And time, which is usually in years. All right, so let's take a look at the first example then. I want to calculate the end value of an account that starts with $10,000 with an interest rate of 1.5% compounded monthly for 5 years. Okay? Round to the nearest cent. All right, so let's write the formula for this. Now I'm going to plug in with what I know. Now remember, the 1.5%, I got to change that percent to a decimal. And it's monthly. There's 12 months in 1 year. And then it'll be 12 times 5. Okay, remember order of operations. So I'm going to do what's inside the parentheses first. So that's going to be this. And we know 12 times 5 is 60. So we're going to take that number to the 60th power first. Again, order of operations. And now multiply by 10,000. Okay. So again, I'm going to round to the nearest cent also. So at the end of 5 years, I'm going to have $10,778.34. Keep in mind that the interest, if I ask for that, is $778.34. Okay, because I started off with $10,000. So there's not much interest has accumulated in 5 years. All right, so let's take a look at one other example then. I want to figure out how long it's going to take me to get from $2,000 to $8,000 if it's compounded daily at 2%. So again, I'm going to write out the formula. And plug in what I know. So I know 8,000 is the end. The beginning is 2,000. Okay. Again, change the percent to a decimal. Okay. And because it's compounded daily, usually 365 days in a year. Okay, so I'm going to divide both sides by 2,000. And now I want to simplify what is inside the parentheses. Now, notice here the equation has the variable t in the exponential power. If you recall, if I can introduce logs into this problem, I can easily alleviate that problem. So I'm going to put the common log of both sides. Because I can do that, I can bring the 365t down. So I'll do that next step. And I can divide both sides by 365 times that log because it's just one number. So the actual answer, t equal to this. Which is approximately 69 3/10. Now, I could figure out the months by taking the remainder here, which is 3/10, and multiplying by 12, and that's 3 6/10. So you're looking at about 69 years about 4 months. Okay. So again, it takes a very, very long time with a very, very low interest rate. Okay, so good luck trying to get all that money before you pass. All right, so the other topic I want to take a look at is continuously compounded interest. So there's the formula for that. Again, A is the end balance, P is the principal or the beginning amount, R is the interest rate in time, is T, usually in years. Right? Okay, so let's take a look at a couple of examples then. So Kev wishes to quit smoking. So he spends $6 for 1 pack of cigarettes and he smokes 2 packs a day. At the end of the year, he puts all that money he saved into an account that continuously compounds at an interest rate of 1 7/500% for 10 years. How much interest will he make at the end of the 10 years? Well, we need to figure out the principal or the amount of money Kev is going to put in first. Okay. So, $6 a pack, twice a day, and then 365 days in a year because we're only talking about 1 year. Well, that should be $4,380. So that's the amount of money he's going to put in. So we'll write it as this. Okay, so 4380, natural base E. Okay. So now I need to change the percent to a decimal. Okay. And we were talking about 10 years. So again, when you do this, remember you're going to take E taken to the 0.175 first, and then take that answer and multiply by 4,380. You should get approximately $5,217.66. Now remember, that's the total amount. That is not the interest. So if I want to know what the interest is going to be, I'll take the total amount at the end of the 10 years minus how much money I put in, which in this case was $4,380. My interest is $837.66. Not bad if you can quit smoking. Okay, so now let's take a look then at Lisa wishes to quit drinking. A bottle of vodka costs $20 and she drinks 1 bottle once a week. After 2 years of quitting and saving all of this money, she puts the money into an account that continuously compounds at an interest rate of 1 2/2500. How long will it take her to double her money? So again, similarly to the previous problem, I need to figure out how much money Lisa's going to be able to put into this account. So money, again, is equal to the principal. So we're talking about $20 per bottle, okay? Once a week, so that's 52 weeks, okay? For 2 years. Okay. So that multiplies to be $2,080. Okay. So again, we'll rewrite. Now, to double her money, well, that's going to be A equal to 2,080 times 2. That's going to be 4,160. So I do know what A is here. That's 4,160. The original is 2,080 times E, and 1 2/2500 I can easily write. Okay. And it's the time that I don't know here. Okay, so solving this, I would divide both sides by 2,080 first. So that's 2. Okay. Now remember, natural base E and the natural log are inverses of each other. So I'm going to take the natural log of both sides. Now remember, you have a property we talked about earlier so that the right-hand side is just this expression. I can divide both sides by that decimal. Okay. So T is approximately 55 and a half. Okay. So again, half of a year is 6 months. So we're looking at about 55 years and 6 months.